So yeah, my name is John, and here I have John
Also
Walker. Today, like you said, we're talking about simulated worlds and the future of computer vision training. So to start, so how does computer vision work? Well, what we do is we create synthetic data, and with that synthetic data, we send it to the modeling team. The modeling team trains their model on that synthetic data, and then they use that to create a real-world evaluation to help the clients solve whatever problems that they currently have. So what does that look like? So on the left of the screen here, we have our guardrails that empower the modeling team to create any kind of synthetic data that they want within those guardrails. So you can have different type of worker variants for worker safety. You can have different types of medical equipment for medical computer science, health sciences. If it's forklifts, they can have different types of forklift configurations, and so on. Then in the middle here, so that's the guardrails. In the middle there is the actual logic on the Unreal side, where it takes those guardrails and creates those variants to create those different types of data sets. And then on the very far right is those different data sets. So you can see here we have different workers for worker safety. They're wearing different gear, and they're doing different tools, different actions to help the to help the modeling team have lots of different variables to train their model on. All right, so let me give you a little demo of what it looks like. So I am going to switch here to our guardrail system. So this is just an example of one data set. So we can have hundreds and thousands of different data sets, all with all sorts of different variables for that particular data set. And again, like I said, this empowers the modeling team to say, oh, we want to have different types of workers. We want to have different variants of those workers. So female 1, 2, 3, and 4, male 1, 2, 3, and 4. If they should have hair or not. What kind of shirt are they wearing? What color is the hair going to be? Their pants, their boots, and so on. And then for this particular data set, it's talking about their medical gear. So are they wearing the gown? What type of gown is it? What variant of gown is it? And what color is that variant? And the modeling team can do all of that. But more than that, they can also alter the type of camera being used, the lighting in the area, the exposure of that lighting, or the exposure of the camera and the bloom of the camera, and how big a capture they have, and so on and so forth. So there's a lot more that they can do than just adjust the variables of the different avatars. So once they have this set up for their particular data set, then they'll go into the Unreal Engine, and they will choose, and in this case, we're going to do worker safety. They'll choose what data generation they want to create. They will import that guardrail, that JSON object, into the application, and then they'll run it. And so what we'll see here is the application running. And in this case, this is just one single data set with one single avatar. And in this avatar, currently doesn't have any safety gear on at all. So this is a nice thing about synthetic data, is that we can do unsafe acts or acts that you wouldn't want to do in a warehouse or in a medical facility or any kind of industry. We can do all those unsafe acts. So while this was happening in the foreground, while this is all what we saw, in the background, every single second, 30 images were created, and those 30 images were annotated with what the avatar was wearing, where it should be. So the safety vest should have been on his chest. It wasn't there. The helmet was supposed to be on his head, and it wasn't there. And you can see right here that we have 355 images generated. So I'm going to go to where that looks like. So again, you can see here, all the images were generated. And this is what we would give the model, or well, the modeling team would give the model to train the model on. And so those are the images. These are all of the annotations for that for each image. So we'll just open up annotation 127. And you can see here that this quadrant is where the eyes were exposed. This quadrant is where the helmet was supposed to be, the gloves and the safety vest and so on. And then finally, this is where it tells the model, maybe I can make that bigger, I'm not sure. But this tells the model like, hey, that avatar didn't have the headpiece on. They didn't have the eye protection and safety vest and so on and so forth. So we can again, like imagine I can do this 100,000 times. And in just that 30 seconds, I generated 350 images. So if I run this for a week, I'll have billions and billions of images of avatars wearing the correct gear, wearing the wrong gear. And then the modeling team can take that and train their model to say, yep, this is what a cat looks like, and this is what a dog looks like. And this is what an avatar without the correct gear looks like, and this avatar with the correct gear looks like. And then they can give that to the client, and the client can use that to empower themselves to make better decisions because they're much more informed. So any questions on the synthetic data side? All right, awesome. Okay, well, I will pass it back to you, Jonathan, sir.
All right. And thank you, John. Good morning, everyone. I'm, again, also John.
Oh, you have it flipped.
Oh, I don't know. 1 second, guys. I did not do that earlier.
Can you do presenter view? Oh, maybe? Oh, no, you are the presenter.
Yeah, I can't see it. Oh, okay.
There you go, there you go.
All right.
There you go.
Sorry about that, guys. Okay, so also John. I want to talk for a few minutes, I guess, about how on the modeling side, we actually use your digital environment, right, to really augment our models. And sorry, I should have said at the beginning, I'm part of SAS's applied AI division. And so having the digital twin environments has just been a huge help for us. If you hadn't had a chance yet to come check out our booth over here in the Innovation Hub, one of the models we have on display there is personal protective equipment, PPE. And it's essentially trying to identify which pieces of gear an individual is wearing, and then figure out, are they wearing the correct gear for the location they're at right then, the task they're doing, et cetera. Now, as you can imagine, this can actually be a fairly challenging detection task. The safety glasses, for example, gloves, they can be pretty small. Also, they may be obscured, either completely, temporarily, partially. So it's really challenging to just find these objects in the given image and then keep track of them. Now, just like any other machine learning model, one of the best ways to make the model more robust is with more data. So hence the digital twin environment. So our team has started putting together a pipeline where we can use this environment to augment the real world training data that we already have. First thing we can do is we've put together basically random level generation. As John said, they have the ability to put all these different avatars, all different PPE varieties of vests, clothes, shirts, pants, whatever. We can now randomize that. So we have a config file that does essentially the guardrails around the level generation, right? What are the allowed values, and then what are the ranges for those values? Run a utility, takes that, samples that space repeatedly, and gets out that JSON like scene specification file that you saw John show. Feed that back into the environment, runs hundreds of scenes, we get back training data, and then feed that into our models, and then we get out a trained model, which then we evaluate on both synthetic test holdout data as well as the real world data. Because ultimately, we're looking for stuff that performs well in the real world. Okay. I'll show you a little bit of that in action. So this is the kind of the generator. Sorry, guys.
Nope, that's on the. No, that's,
We just did this.
there you go.
That's what breaks it.
There you go.
So this is our parameterization file. See at the top, it's just how many scenes do you want to generate? We give a prefix to each one just so it's unique, so we know what it's for. Again, we'll keep with the worker safety theme for today. We set a resolution for the output images. Right? So if we want to say, let's just call this, and we'll make this like later. We want to use the industrial safety workers. The levels have some predefined camera positions already, right? Left, right, front, back. So we can say, all right, use those, but then we want to offset them. And we give ranges to those for different allowed values. So we get slightly different, but nothing too crazy. So we can, in skew, we've got yaw values here. The post-processing stuff, again, you saw it in the JSON. This is kind of what drives what can end up in there. Minimum, maximum number of workers per scene, how many things they can be doing, right? Probability of different avatar variants, male, female, do they have hair, beards, different PPE objects that they could be wearing. We've got hairstyles, here's PPE, for example. So if we look at hard hats, we've got 3 different variants of hard hat right now. We can just select between and set colors for each of those. So for things like hard hats or PPE, they tend to have pretty specific colors. So what we actually do is we set kind of an anchor point. So this is yellow, right? So 75% of the time we're gonna have yellow hard hats, approximately. But then we add in some randomly sampled noise, normally sampled noise, so that nothing is exactly the same, right? Because there's always a little variation. We could say, for the different types of helmets, which ones are more or less likely to be worn in a given scene. Now this is a great example of something that's been a fantastic tool for our team. When we started this, all the hard hats were, say, yellow and white, because that's what we thought hard hats were. And then we started talking to a customer, and they, for whatever reason, they have blue hard hats. And we said, no problem, we can do that. We come in here and put in blue as an option, and we can tweak the colors, and we get it to just match exactly what hard hats they use. Regenerate a bunch of scenes, and now the model knows what blue hard hats are. Similar thing with safety vests, orange and yellow, but we found that some customers use different colored vests to designate or denote the role that people have, right? So, seen blue vests, green vests, put all that stuff in here. Then we get, shirts, pants, et cetera. These have more ranges, so it's just kind of, here's a bunch of colors, but within reason, right? So we can change kind of how, this is HSV value, so how saturated, how bright. Close PPE, so you get the idea. And then we can just say, all right, let's generate scenes. We want to use our sample params. Let's just make 3 of them. And we'll say, and we always always want at least 2 people in there. If I typed everything correctly, this should just think for a minute. It did not. I'm missing a little dash there.
And so what you're doing here is you're creating the specific guardrails to generate the synthetic data, right? You're creating the data sets for each.
Absolutely. So we are creating, so we're running the scene generation. All right. Obviously, I can't remember the parameters off the top of my head without enough coffee this morning. So what we end up with here is still a JSON file. It should have 3 scenes in it. All right, you see, for each scene, we've got now 4K resolution. So this is the specific, out of that parameter space, these are the specific ones that were picked for this given scene. Right? So we know, as John said earlier, here's kind of the camera position. Here's what got sampled to go in here. So male number 2 who's got a mustache and looks like dark black hair, See, he's wearing his hard hat, right? And the nice thing is, it was randomly generated, but if we need to come in here, we can tweak this, we can add stuff. It's all fixed at this point. And we take that, unfortunately, I can't run the Unreal Engine on my laptop here, but you saw earlier, we take that JSON file, load it up, literally within minutes, we can have results back. This is some of the training results again. This particular I'll call out that's hugely helpful for us. The labels, the key points, et cetera, that John showed, standard output for computer vision annotations. But it's every individual frame. The fact that the model gives us kind of the ground truth for all frames in the video is incredibly helpful, because any frame in particular, like, yes, we know there was supposed to be a hard hat here, right? Or there was gloves here, we've got the bounding box. This tells us, no, it was this person was wearing that PPE. So it's no longer just the computer vision piece itself, it's tying all that together, the actual detections, and then to the people that were detected in the scenes, and making sure that ultimately the ground truth for the overall model is accurate.
So you mean if there's more than one avatar in our synthetic scene, that this document you're looking at here will say avatar 1 was wearing a hard hat, but avatar 2 was not.
Absolutely.
And that helps train your model even further, right?
Absolutely. Let's see. I don't know if that came out in this particular random scene, but yes, if...
Well, this one, the avatar 1 is wearing eyeglasses.
Thank you. Yep, so we detected eyeglasses. We know who those should be associated with in the final model.
Yes.
Otherwise, it's just kind of eyeglasses out there by themselves.
Yeah, and you get the bounding box for each avatar as well,
For every
right?
frame, yeah.
Yeah, great.
And you can see, these are just a couple frames, not from the same scene, but just to give you an idea of some of the variability that we can get very, very rapidly. And it's all literally the same level, just combination of different avatars, different pieces of clothing, different colors, different camera views, doing different tasks. Okay. So once we've kind of done the training, we get out the resulting model. Obviously, the next step is we want to evaluate it. So what you're seeing here is actually a video of, this is, obviously real world video, but the annotations are being done from our model trained just on the synthetic data. And you see it does a pretty good job of picking up everything. Gloves are challenging because the hands are moving back and forth all the time. But every time he lifts his head up, it can see, oh, there's safety glasses, right? As opposed to Brett here, who is being naughty and not wearing any gloves. And it very accurately picks up on that, even though it's never seen him in any training data. So a couple of takeaways I'll leave you with. For us on the modeling side, like the incredible value for this has been obviously just the sheer volume of data we can collect. Anytime you have more data, you get a more robust model. there's a lot of open source, publicly available data sets, and they're hugely helpful. We use them whenever we can. But we've also found that for certain industries, sometimes those data sets aren't as applicable. Even just, basic example from computer vision, there's a lot of person detection data sets out there. But the perspective you have for, say, like your doorbell camera, person detection is not the same as like a security camera or a camera in a warehouse, for example. So being able to generate data that matches the environment the model's actually going to be deployed in lets us make something much more efficient. And then variety, both good and bad. So on one hand, we can make data that is, a ton of variety. We have all the different permutations of PPE, height, weight, colors, sizes, et cetera. It's also very easy to add new stuff. So some of you guys have been at our booth the past couple of days. I've noticed you're wearing backpacks, right? And so showing up and seeing these straps, and the model was never trained on backpacks. It doesn't know what those are. So it looks at these and goes, oh, that's a safety vest. Right? But now we can go back and ask John for some backpacks, throw them on, and very quickly get that data. Teach it the difference between backpacks and a safety vest. We also can eliminate the bad variety. So if you've ever done any manual annotation of images, it's painful. I think if you give two people one image to annotate, you'll get at least 3 different ways to do it. So it's just a pain.
Also takes a really long time to manually draw the quadrant for, like, this is where the helmet is for image 1. Okay, image 2, this is for the quadrant 1.
It is
And,
really terrible.
And when we generate that synthetic data, we're doing that on the fly. So that 30 seconds we created that video, it was all annotated automatically.
And it's consistent. It's perfectly consistent, which is just, it's less noise for the model to have to figure out how to deal with. It also means because it's so fast, we can prototype more. We can have an idea and we can play around with it. We can try new stuff. Whereas before, because the annotations are so painful, we'd say, well, that'd be cool if we had the data for it, but we can't get it. It's, now that we can do it in minutes, days instead of hours, or instead of weeks or months, right? It just opens up the doors to a lot more experimentation. And then specifically maybe for the industrial safety side of it, some of the most important, most impactful events you want to find are the ones that thankfully you don't really have a lot of examples for. So that's a huge challenge without synthetic data. For some other cases, we've been able to either simulate some of those scenarios internally or work with our customers to simulate them. But there's also stuff you just can't feasibly simulate in a safe manner. So having this environment gives us an avenue to build models that can actually detect some of these situations that we could never just do before at all. And then finally, because the synthetic data doesn't have any personal identifiers in it, right? It's safe to analyze and share even in highly restricted industries. And you can still meet the requirements set forth by, like, say, GDPR or HIPAA, right? Where you could not do that with public data sets or even things if you go on site and collect, we'd have serious problems. So all in all, it's been a massively fantastic tool for our team.
All right, thank you.
Thank you, guys. Any questions?
Oh, no.
Yep. So we're working through it right now. Actually, we want to do some experimentation. We know that, like, for example, lighting conditions, computer vision models tend to be very sensitive to different lighting conditions. So in the past, we have to go out, I need data for in the morning, in the afternoon, in the evening. Now, we can just literally get all of that same time. That's going to be especially important as we move to more outdoor models. And then we think, colors and patterns, especially local colors and patterns, are what we expect the models picking up on the most. Whereas some of them more like effects that are great for video games, I don't think are really going to make much of a difference for the model. So.
Any questions? There we go. All right. If there's no more questions, thank you very much to our presenters.
Thank you.
Yes.